CIS 257. This is roughly week 5. And today, as promised, what I would like to look at is the next challenge. Of course, the quizzes being posted and everything. So our next challenge is to develop the desktop calculator for arithmetic expressions that I mentioned a couple of weeks ago. That will be our focus. So we're essentially, let me just say that we're having been and where we're going, basically. We would like to continue exploring situations where we have classes that inherit from one another, right? So we use this type of diagram a couple of weeks ago to say that this is our superclass, right? And this is our subclass. We can basically develop or design our projects using superclass and subclass. We also discussed things that the references to superclass can be used in inheritance of objects, so that multiple classes can inherit from the same parent class or superclass, and we can create basically a collection of references and store references to the superclass in this collection. But when we call methods on this superclass public interface, the methods are delegated to the actual implementation classes, and this is something we refer to as polymorphism. We also mentioned interfaces, right? There's a Java interface, an idea of Java interface, and we will be, generally speaking, going in this direction, talking more about inheritance, talking more about interfaces, talking more about polymorphism. But before we do that, I would like to get started with the project, which will occupy our attention to basically homework, set of homework ideas, which will be specific to another interesting aspect aside from inheritance and the things related to inheritance, which will be recursion and basically looking at some aspects of data structures and the way we can do things. So with this in mind, the latest homework, assignment 3, I think you should print it because it has a lot of information for us to go over and digest, but I will just briefly reiterate what we tried to talk about last week. This is basically both homework and handout for you to look at. You definitely need to study this, and I have some sample code to start with. So anyway, let's just reiterate what we are going to do. So we said that when we would like to develop a version of desktop calculator program, right, which basically uses a console screen and goes to a prompt of some kind, and the user can type expressions such as 2 plus 3 multiplied by 5 and hit enter at the end, right? And it should basically give them the right answer. So in this case, multiplication 3 by 5 is 15 plus 2, which is 17. So it should print 17 on screen, right? And then go prompt for another expression. So they can keep typing other types of expressions, and again hit enter, and they should be getting their answers, and the program goes right back to the prompt. And the challenge is that we would like to develop this desktop calculator so that, of course, it is capable of understanding the fact that the user can prioritize the work to be done in terms of understanding what the expression is, and perhaps they can use parentheses and say 2 plus 3 should be evaluated as 1 unit, and then it should be multiplied by 5, right? So the outcome of this and this is different, because 2 plus 3 is 5 times 5. This should print 25 compared to 17. And so now we're going to go back to the idea of what possible solution could we use for this challenge, because there seems to be quite a bit of things that are involved in this desktop calculator program, right? And so the first thing that we would like to discuss is that we can say that 1 plus 2 plus 3 could be represented by introducing a special data structure, which is going to be a combination of classes that we use at runtime. But basically, if we could represent 1 plus 2 plus 3 as plus, which is an operation, which then operates on another plus, right? And which in its own turn operates on the value 1 and 2, and finally adds 3 to the picture, then we can say that if we could have basically redone this somehow, basically constructed an interpreter of this text entered by the user and converted to a data structure like this, which is typically formally called AST, which is Abstract Syntax Tree. Then what we could do, we could then build an interpreter that basically would start at the top and say, in order to do the computation, what I need to do is that I need to go to my left-hand side and to my right-hand side, right? So on the right-hand side, it's trivial. The value is 3. However, on the left-hand side, there is another operation that needs to be performed. So we will basically temporarily delegate the work to this level, and this one should go to pick 1 and 2 as its own left and right sides, compute 1 plus 2, which is 3, and come back with its own result 3, which it returns to the top level operation, which finally says 3 plus 3, and then the result of this computation is 6. Okay, so that's first, this is the direction in which we're going, and I've written some sample code which will be helpful to what we do, and we will soon explore that.